Students, we discussed with BFS algorithm in last sessions. On the next topic with graphs is DFS algorithm. That is depth first search algorithm. In the breadth first search algorithm, we will be finding the minimum path from one node to from the destination node to the from the destination node to the end node, from the source node to the destination node. With the BFS, we are finding the minimum path from source node to end node. The same kind of notation, the same process we are doing with the DFS algorithm. What is the difference to DFS and BFS is, in a BFS algorithm, we are traversing breadthwise. In a DFS algorithm, we are traversing deeper and deeper until we find our desired node or until we move to a leaf node. That is the node that has no children. So what we are doing with the DFS, the same process. BFS and DFS are used for same process for finding the minimum path from source node to the destination node. So the BFS will follow breadth first search, that is taking following in a breadth wise order, level 1, level 2, level 3, level 4. That is the order followed by the breadth first search. Whereas in depth first search, we will move to deeper levels, root to child, child to child, child to child. Like that, we will be moving to deeper levels. Moving to deeper levels until we reach our desired node or until we reach to leaf node. So now with the BFS, what we are using is, we are using the structure of queues in BFS. So we are using two queue structures. One is for inserting elements into queue and the other one is for storing the deleted elements from the queue. One queue structure is used to insert values and the second queue structure is used to store the deleted elements from the Q1. So here in DFS, we are using stack data structure. In order to process that DFS algorithm, what is the data structure we are using is, we are using stack data structure. So now as similar, the same algorithm is same to BFS algorithm. Setting status equals to 1, taking a graph, making all the nodes of that graphs to ready state. Set status equals to 1, make all the nodes in the graph to ready state. Now as we are using stack structure, push the starting node to stack, pushing the starting node into stack. So then what we are, ready state element is moved to stack, then it comes to waiting state. So when it is moved to stack, it is processed. Then what happens is, it is processed, that is pop the top node from the stack. So whatever the node that we pushed into the stack, it is the top node, it is the top element on the stack, that is the top node. So now pop the top node. So that means the its status becomes 3. So what we are doing, first we are making all the nodes in a graph to ready state, and then we are moving first node into stack, making it waiting state, and again removing that node from stack, making it to processed state. Pushing into stack, popping from stack. When pop from the stack, what we are doing, the first element is popped from stack. Now what the elements to insert into stack? All the neighbors of the popped element. What are the neighbors of the popped element? Those will be entered into the stack. Push all the neighboring nodes of push all the neighboring nodes. See, after deleting, push all the neighbor nodes into stack which are in ready state. Push all the neighbor nodes into stack that are in ready state. Now we discuss with the following example. Consider the following graph with a set of vertices and edges. Now calculate the find the order of traversing of all the nodes. Now I need to move from node H to last node G. All the nodes, I have to traverse all the nodes. What is the minimum path in traversing all the nodes? So from which node we are starting is, we are starting from node H, depth first search. We are starting from node H and we need to traverse all the nodes. So starting from H, what are the adjacent nodes to H? So H is connected to A and H is connected to, what is the adjacent node to H? H is connected to A, and then so adjacency node is A. H adjacency node A. For A, B and D are the adjacents. For B, C and F are the adjacents. For C, E and G are the adjacents. For D, F is the adjacent. For E, B and F are the adjacents. For F, A is the adjacent. For F, where is F here? F. For F, A is the adjacent. G, E and H are the adjacents. E and H are the adjacents. Now coming to the algorithm. What we are doing here? Push H onto stack, taking a stack frame. I am taking a stack frame. You know what the stack frames is. Now push H onto stack. Pushing H to stack. After pushing H to stack, that is the H is in ready state, so pushed into stack. So after pushing into stack, it becomes a waiting state. After that, it becomes processed state. Now pop the element from stack. H is the popped element. Now what are the neighbors of H? Then what we had after popping H, what we need to do? We need to push all its neighbors. What are its neighbors? H neighbors. What are the adjacent lists of H? A. So now push A to stack. Now we are pushing A to stack. Now what I am doing is A is pushed into stack. It becomes a waiting state. Now I have to pop it from the stack as it is processed. Pop to stack. So A is visited. So pop it from stack. What are the next adjacency nodes of A? So what are the adjacency nodes of A? B and D are the adjacent nodes. What are the nodes? D. I am having nodes D. I am having node B. So as we are representing depth first search, we have to take the nodes from this notation. HA, A to D, and then I have to move A to B. Depth first search కాబట్టి ముందు lower order లోకి రావాలి. That is, we need to take first deeper nodes and then we will move to the next nodes. So what are the nodes adjacent? D and B are the adjacent nodes. So now pushing B, no problem, taking B or taking D, whatever it is. What are the adjacent nodes of A? B and D are adjacent nodes. So taking B and D, pushing D into the stack. Now pushing B, pushing D into stack. After pushing into stack, they becomes processed state. Now pop from stack. Pop means popping top element. D is popped. After popping D, then what are the neighbors of D? F. F enters into stack. Now F is processed. F popped out. What are the neighbors of F? A is the neighbor of F. It will not be processed. It will not be entered into queue because already we visited A. So it won't be inserted. Remember. Coming to F. F is popped out. Its neighbor is A. As we visited A, so no need to push A. Now what is the element? As there is no push, now B. So this is popped. Now pop B from stack. What are the immediate neighbors of B? C and F are the neighbors of B. So what are the neighbors of B we are having? B neighbors F and C. So B is processed, F is processed. So no need to write F. Then what is the node that is having? That is C. So now C will be processed. So now delete C, pop C. What is the neighbor for C? G and E are the neighbors. So G and E, C, G and E are the neighbors. Like this, C, we are having C, G, okay. E and G are the neighbors. C, E, G are the neighbors. So now G is the top element removed from stack, and then G, H is processed. Then what is the remaining element? E, that is popped out. This is the direction. H, A, C, H, A, D, F, B, C, G, E. This is the route we have been representing. Hope you understand. Once again, I am saying about this stack representations. Check it while see. this is the graph we are having. Already we have been this is the graph. This is the graph we are having. Now representing it with the then representing it with a stack frame. So consider this as a stack frame. I am not able to draw properly because of holding video here. Now first push first starting element. H is the starting element. So it is the starting element pushed into stack, then pop it from stack. Visited. It is visited node. Pop it. Next, what are the neighbors of H? So A is the neighbor of H. Push A to stack. It becomes visited. Remove A. Then what are the neighbors of A? B and D are the neighbors of A. Now insert B, insert D. B, D. Immediate neighbors of A. B and D are the immediate neighbors of A. Insert them into stack. Now pop the elements. D is popped. What is the next neighbor, immediate neighbors of D? Immediate neighbors of D is F. Push into stack. So now this is the top element. Now pop F from stack. Pop F from stack. It is deleted. Now what are the neighbors of F? A. It is visited. So no need to pop. Then we need to, then no need to push, then we need to pop. So pop B from stack. Popping B from stack. Now what are the neighbors of B? Neighbors of B is F, which is visited. Neighbors of B is C. So now insert C. Insert C. Now pop the C. Now what are the neighbors of C? So neighbors of C is E and G. So neighbors of C, E, immediate neighbors E and G. So now remove G, pop G, top element. What are the neighbors of G? H and E. H already visited, no need. And then pop E. This is the final representation. So practice this. In the next session, I will be clarifying the doubts with regarding to BFS and DFS.